Let's get the next session started on sustainable transportation. So before we start the panel discussion, let me give you, a setting stage talk introducing our StorageX Initiative. So let me introduce StorageX Initiative to everybody. About 3 years ago, and under Arun and Sally's leadership and pre-court, we launched this new initiative by recognizing how important storing energy is. Professor Will Chu and myself, under the help of Jimmy Chen, Managing Director, and also we have a team, we have Kaylee, we have Tracy. We spent about a year to plan for this initiative and launch in 2019. So let me share with you, so what are the key problems we want to address? Indeed, from Steve Chu, from Arun's talk, you already see it. For the mobile power, and we are seeing electrical transportation, we hope the electricity can also power aviation as well. There's a really big opportunity right there. Let's just look at transportation as an example. About 1.4 billion cars, trucks moving in the world. Assuming we need to use 70 kilowatt hour per car. So this is 100 terawatt hour of batteries we are talking about. And also, by the way, with 30 years of lithium-ion batteries commercialization, with all the capacity built so far and also all the capacity committed, not yet built, the world production per year is only 1 terawatt hour per year. This will take 100 years. This is the scale of the problem, as well as the opportunity as well. Well, in terms of money, this is $10 trillion market, assuming it's every 10 years, change the batteries. So this is at least $1 trillion per year. Also, a lot of investments are needed to build up this capacity. Well, let's look at now grid scale. And with solar and wind electricity integrated into the grid, you need to stabilize the grid. There's minute to minute, hour to hour, day to day, and eventually seasonal storage. So this probably requires different technologies to come in. Steve Chu earlier showing you, hey, pump hydro is still one of his favorite right there. But let's look at the electricity consumption. 2019, this is a gigantic number right there. So what does this mean? If you will store the electricity, the grid, for 3 days, for 72 hours, if you will use batteries to do it, this is a 200 terawatt hour. You will appreciate a lot more what Steve said, for batteries to get there is challenging, right? But the scale is big. For people working on energy storage, we ask the question, what are the solutions? Is pump hydro, is a combination of batteries with hydrogen? But I want to present you to the scale, measure using battery, 200 terawatt hour, by the way, another 200 years to produce, right? So given the current production. So that translates also, it's a $20 trillion market right there. So the grand challenges for energy storage. Now let me list in form of batteries. Certainly at Stanford right here, we consider other form of energy storage. Let me just use the batteries to throw the question here. Hey, how do we store energy? How high the energy density can we go? Measured in watt-hour per kilo, watt-hour per liter. The higher we can go, the more areas, the application we can impact, particularly aviation. What about the lifetime under the realistic condition? 30 years, 30,000 cycles. So what about the charging speed? Can we do very fast charging within 10 minutes, within 5 minutes? Can we make the batteries completely safe? Can we reduce this cost 3 times? If it's even better, if you can do an orders of magnitude. that can make the seasonal storage getting close to be real using batteries. What about mining and reuse and recycling? And eventually the largest scale stationary storage. So these are the grand challenges, problems we want to address in StorageX. At Stanford right here, we recognize to address the challenges like this from innovation, you need to go down to atomic scale, molecular scale, all the way to the system scale. It's really multi-scale of innovation. You know, in chemistry and material science, we are dealing with to atomic scale. And mechanical engineering, and you go up one scale more, right? This is really multi-scale problem. We need to bring in all the expertise on campus together to do it. And over the past number of years, we have built up an ecosystem with about 20 labs working on energy storage and bridging all these landscapes. So let me also saying throughout this process, co-innovation with industry is very, very important in StorageX. We appreciate your support, your input to work together. There's actually many exciting research programs established between industry and Stanford faculty to really address some of those challenges outlined in the previous slide. Let me also mention at the StorageX, we really want the technology translation to be smooth, to be as fast as we can. Over about a decade long, in Stanford ecosystem, there are now about 10 battery startup companies coming out of this ecosystem. This will continue to generate more.